Welcome to The Explainer. You know that feeling when you open a file expecting to find one thing, and instead you're hit with a wall of, well, just gibberish? Today, we're diving into a strange case of digital decay. We're going to crack open one single broken document to see what story it has to tell.
All right, so this is where our story begins, with a document that was supposed to be a lesson on Unit 3 Pharmaceutical Microbiology from a company called Carewell Pharma. Looked pretty straightforward, right? We figured it'd be a standard chapter from a science text.
But yeah, the moment we opened it, it was obvious something was seriously off. Instead of that science lesson, we found this digital mess. The information we wanted wasn't just gone. It was like it had been replaced by something else entirely. So what did we find inside? Well, it wasn't diagrams of cells or notes on sterilization, that's for sure. It was just a chaotic jumble of text. What should have been a chapter from a textbook was, well, you'll see. Take a look at this. This is a real sample from the file. Now, at first glance, you might think, is this some kind of code? But it's not. It's just digital noise, pure randomness. And here's another bit. A bunch of symbols, plus signs. It almost looks like part of an old math problem, but it means absolutely nothing. It's completely nonsensical. This one really shows you how bad the corruption is. It's like the ghost of a sentence, a mix of letters and symbols that just doesn't make any sense. And this wasn't just one bad page. The entire document was like this. So this leads to the big question, right? What on earth happened here? Where's the actual lesson? And what is all this digital garbage that's taken its place? That's the mystery we set out to solve. To figure this out, we had to become something like digital archaeologists. The clues weren't in what was missing, but in the pieces that were left behind. It was time to sift through all this chaos and hunt for any patterns we could find. And you know what? As we dug through all 22 pages of this mess, a very strange pattern started to pop up. All the content could basically be sorted into two piles. On one side, you have the random noise, all the gibberish we just saw. But on the other, there was a constant signal, phrases that were perfectly clear and repeated themselves again and again. Let's focus on that constant signal for a minute, because scattered throughout all that nonsense, this one message kept appearing. Search Carewell Pharma on YouTube. That, plus things like subscribe us and watch videos. It's not a microbiology lesson, it's a marketing pitch. And just how constant was this signal? We're not talking about a couple of pages. It was on all 22 of them. Buried in the noise on every single page was the exact same promotional message. Now that was our biggest clue. So this gets you thinking, what kind of process could perfectly save a header or a footer across 22 pages, but turn all the important content in the middle into complete gibberish? Well, this points us to our prime suspect, the ghost in this particular machine. It's a technology called optical character recognition, or OCR for short. And all OCR really is the tech that lets a computer look at an image of a document, like a scan, and convert it into actual text that you can copy and paste. So here's our theory. Step 1, somebody scanned the pages from a physical textbook. Step 2, they used OCR software to try and interpret that scan. But, and this is the most important part, Step 3, the software failed. It could easily read the clean, simple text in the header and footer. That's why the Carewell Pharma ad survived. But it completely choked on the dense, complex layout of the main textbook content, and it spat out all that garbled noise we saw. So what you end up with is this massive gap between expectation and reality. You were supposed to get a clean, useful science lesson, but what you actually got was a 22-page ad for a YouTube channel mixed in with a whole lot of digital junk. The knowledge was completely destroyed in the process. So, okay, we solved the mystery of the broken file. But this little investigation, it tells a much bigger story. It's not really about microbiology. It's about the nature of information in our digital world and how surprisingly fragile it can be. So what's the real takeaway here? Well, for one, it shows that digital information isn't permanent. It can rot, it can decay, just like a physical object. It also shows how these hidden technologies, like OCR, act as gatekeepers to our knowledge, and sometimes they're not very good at their job.
Really, even a broken file can tell a story, and it's a powerful reminder to always think about where our digital information comes from and whether we can actually trust it. We started with just one corrupted file, but it leaves us with a much bigger question to think about. In a world where so much of our information is being scanned, copied, and converted, how much of our collective knowledge is just quietly being lost in translation, one broken file at a time?